Hello everybody, today we're going to talk about an exercise and we're going to do it together. So the exercise is like this. We have here an edge, a table edge. We have here a mass M. This is a pulley, a frictionless and massless pulley. We have here a string, a massless string, and we have here another mass. M1 equals 1 kilogram, M2 equals 2 kilogram, and we have mu, which is the kinetic friction coefficient of this plane with this mass is 0.1, and we have g, which is the acceleration of the gravitational acceleration, and it is 10 meter per second squared. And the question is, what is the acceleration of the whole system? Okay, the first thing we have to talk about is which kind of method we're going to use to solve this problem. And in this kind of problems, we're going to use dynamics method. Okay, so in this method we have several steps. The first step 1, is to choose frame of reference. Okay, let me correct this. Frame of reference. Step 2, we're gonna determine the forces acting on the whole system. Step 3, we're gonna apply the Newton's law of motion. Step 4, we're going to project the equations onto the frame of reference we chose in step 1. And step 5, we're going to solve the equation. Oh, what happened? We're going to solve equations. Okay, so we're going to do it step by step. Step 1, what do we have in step 1? We're going to choose a frame of reference. So obviously the system will move like this. This mass will move down because of the pull of gravitational force, and this mass will move on to the right, to the right, because the string will pull it to the right. And for ease, we were going to choose the frame of reference like this. For mass M2, we're going to choose it vertically and downward. And for M1, we're going to choose it like this, to the right. So that is step 1. Step 2, we're going to determine the forces. The forces here, I'm going to draw it again. So this is the pulley, and M1. No. Just going to delete the M1. This is P1, and this is N1, which is the normal force of the table acting on the mass. And we'll have T1. This is we'll have P2. This is T2. Very good. And because we assume that the whole system will move like this, so there will be a friction like this acting on M1 like this, and resisting the motion. Okay, so this is step 2. Step 3, we're gonna apply the Newton's law. The Newton's law here, for first object, for M1, we have P1 plus N1 plus T1 plus F friction equals M1 and A1. For M2, we have P2 plus T2 equals M2A2. Alright, and step 4, we're going to project the equations on to the frame of reference. So for M1, we're going to project it onto this axis, and we have, because P1 and N1 are perpendicular to the axis, so the projection onto the axis are 0, and we only have frictional force and tension force of the string. Okay, I'm gonna draw a horizontal line here, and we have, what do we have here? We have minus F friction plus T1 equals M1A1, and P2 minus T2, I'm sorry, equals M2A2, and this is the equation system. We have as we can see here, we have 4 variables, T1, T2, A1 and A2, but in fact we have 2 more equations here, because the pulley is massless and frictionless, and the string is massless as well. So we have T1 equals T2 in magnitude, and also because the string is unstretchable, so A1 and A2 must be equal in magnitude, and we also have F minus F friction plus T equals M1A. P2 minus T equals M2A. I rewrite T1 and T2 into T, and A1 and A2 into A. So we're going to expand these equations. We have minus mu n, n is the normal force, and we have n equals P1, because the mass have no acceleration in this direction vertically, so N1 must be equal to P1. the first law of the first Newton's law, mu mg plus t equals m1. This is m1a, and m2g minus t equals m2a. And from here we add the two sides of the equations together, so plus t and minus t cancels each other, and we have m2g minus mu m1g equals a m1 plus m2. From here we can get a equals what? A equals g m2 minus mu m1 over divided by m1 plus m2. So this is what we have from all the steps we described in the first place. So look at the results. We can see that obviously A is proportional, directly proportional to G. So it means that if the gravitational acceleration is high, we have high A. It means that if we do this experiment on Earth, we will have a larger acceleration than when we do this on the Moon, right? Because the gravitational acceleration on the Moon is much less than the acceleration on Earth. And okay, it depends on m2 and m1, and of course also on mu. So we can see here the minus sign. It means that if m1 is large and mu is large, we'll have less acceleration of the system. That is quite intuitive if we consider the system without doing any equation. We can guess that at the first place. Okay, so that's it. That's our problem solved. Thank you very much for paying attention, and hope to see you in another video. Goodbye.